Welcome back to continuing coverage of IBM System 390 announcements serving new expectations. I'm Walter Cronkite. As you probably know by now, IBM today unwrapped 18 new ES9000 mainframe processors, 8 air-cooled and 10 water-cooled. Here's an in-depth look at the announcements and 2 reports on customer feedback.
Hello, my name is Richard Cummings, and I am Manager of Large Systems Marketing and Planning for IBM US. I'm absolutely delighted to be here today to share with you our product announcements. With me is Roger Luca. Roger is our planning manager in the Enterprise Systems line of business and is the person that is responsible for bringing this product to the marketplace. Roger, if you could you share with us the past couple announcements, the evolution of the ES9000 since September of 1990?
Well, as you mentioned, Richard, the ES9000 was launched in September of 1990. Since that time, we've added new models and new functions in progressive steps. In April of 1991, again in September of that year, and most recently in June of 1992.
And Roger, those have been very successful in enhancing the function and the reliability and the performance. What are today's announcements all about?
Today's announcements are the most significant in my mind since the original introduction in September of 1990. We have 10 new water-cooled models, 8 new air-cooled models, and a number of significant value-add functions for our customers.
That is very exciting, the value-add functions, Roger. As you and I have discussed before, one of the most important ones would be data compression. Could you comment on the data compression for us?
Right. Data compression is a function that is focused really on lowering our customers' cost of computing on a System 390 platform. We've embedded in the hardware a data compression function that allows us to lower the processor resource required to do compression by a factor of 5 to 1 when compared to software implementations.
Well, that's terrific, Roger. Who will be able to exploit this new function?
Our customers should be able to exploit this function very early on. One of the positive things about data compression is we have a comprehensive IBM software support strategy. DB2, for example, will be the earliest user, followed by subsystems such as IMS, DFSMS, and VTAM as well.
How about customers that have what I would call a mixed CPU environment, customers who have the new machines as well as, let's say, a current 900? How will they be able to implement data compression?
Anytime you do a new strategy like this, you need to have a migration or a compatibility function. For example, a new machine sitting next to a 900, as you mentioned, will be able to communicate via software. The hardware function, as long as I'm on the same release of software, can be compatible for things like backup and restore. So there's not an issue where all machines have to be at the current level of hardware.
I see. Now, what kind of DASD savings would you expect to be able to see with the new data compression?
40 to 50% is a good rule of thumb. However, we're seeing samples as high as 70%. For example, a 100 gigabyte file would be reduced to 30 gigabytes in size with a 70% compression ratio. That's a significant DASD savings for our customers.
That is terrific. Now, are there any other savings that could be associated with data compression, perhaps maybe some line savings?
When you look at the communications environment, customers more and more are using high-speed lines for their data communication needs. What data compression will allow you to do is put more data on that line, thus effectively raising its utilization. You can expect improvements in response time as overall line reduction costs.
Now, is this what we would term a coprocessor or hardware implementation? Exactly how did you implement this, Roger?
What we've actually done, Richard, in looking at the compression world, if you will, is look for standard algorithms. What we have done is adopted some standards that are emerging in the industry and actually put them in to the hardware of our machines to effectively make it run faster. In that sense, it is a coprocessor.
Now, will the algorithm that you refer to, that you've embedded in the hardware that you've said would be probably 5 times faster than software, is the algorithm the same in the software that IBM will be using?
It sure is. That's how we achieve the compatibility that I mentioned earlier. By having that same algorithm in both hardware and software, we can ease customers' migration questions as well as provide them effective backup restore situations.
What other ones are you announcing today as well?
Another function which I think is quite interesting to our customers is something called the asynchronous data mover. It's asynchronous because it does not use the central processor to effectively move data between central and expanded storage.
Okay, now moving data between central and expanded storage, is this exploitation of some features you've had before, data in memory?
Well, it certainly is a data and memory exploitation. The whole goal is to allow things such as query applications to process faster by putting more data in memory. We expect with the asynchronous data mover, customers can see 20% improvement in response time for query applications, as well as not involve the central processor in affecting these storage moves.
Now, will this be used in conjunction with the compression that you were talking about before?
It's very likely that it could be. We're still looking at that type of benefit, but there could be, in fact, enhanced value by combining compression and the asynchronous data mover.
One of the things that my customers in the United States have been focused on a great deal, and I know you've worked very hard to respond to, is 24-hour-a-day, 7-day-a-week operation. With this announcement, have you been able to bring any new features or functions to assist customers in that arena?
We sure have. In September of 1990, we really embarked upon an aggressive availability strategy. We've certainly seen the fruits of that over the last several years with the high availability of our systems. One of the functions which we're introducing is the ability to add patches to the system non-disruptively. While we have some of that capability today, we're adding further to that function with this announcement so that our customers will not have to take machines down to do IBM maintenance.
One of the things that our customers say, though, is application availability is absolutely critical, especially in the CICS arena. A while back, you brought out CICS data spaces. Could you comment on what you're doing with CICS today?
Well, in September of 1991, we introduced subsystem storage protection, which prevented CICS and applications from colliding with each other and causing unavailability situations. What we're announcing is a statement of direction, or a strategy statement, that we're going to eliminate CICS application-to-application overlays. Now, as CICS grows in importance in the transaction processing industry, it's our commitment to make CICS the highest availability transaction processing system on the ES9000.
What other design implications or enhancements have you been able to make in the ES9000 line in order to try to achieve 24/7?
Well, over the past several years, we've added things like concurrent CP/TCM maintenance, concurrent power subsystems. We're really fine-tuning that strategy now, and the concurrent patch update is just one example. In addition, we've added some more redundant data paths within the systems. We've collapsed the number of components required. All those things attack the availability question that our customers are so keen on.
Roger, you've commented on 24/7. How could we translate that into real value to our customers?
Richard, the new ES9000 systems that we'll start shipping in February are by far the finest machines we'll ever ship from the Mid-Hudson Valley and worldwide. To translate that quality into a guarantee to our customers, we're announcing the ES9000 Satisfaction Guarantee, as you see before you.
What would be the key to this satisfaction guarantee, Roger?
The net of the satisfaction guarantee is if you, as a customer, are dissatisfied with the quality and reliability of any ES9000 installed after February 9th, we'll replace it, no questions asked, the customer's call. We're that confident of the quality of our systems that we're willing to put our money where our mouth is.
My call as a customer. No ands, ifs, or buts?
If you read the satisfaction guarantee, it says within 1 year of purchase, if you're not satisfied with the quality and reliability, we replace it, customer discretion.
I would say that you are fairly confident then in the quality and reliability. That's terrific.
If you look at the track record of the last several years, the existing ES9000 have been performing great, and these are just one more evolution on the quality curve we're taking with these systems.
You mentioned, Roger, at the beginning that you had 10 new models of the water-cooled processor line. Could you take us through what the performance ranges are of the new processors?
The new processors, starting at the water-cooled model, are about 30% faster than their corresponding ones, depending upon environment. So that's uniprocessor to uniprocessor. If you look at the very high end, the new 8-way system, for example, it's about 60 to 70% performance improvement over today's existing Model 900. So from top to bottom, there's a significant performance improvement. In fact, at the high end, you find that the 8-way is the world's largest single processor supporting the 390 architecture.
Now, there's been a lot of questions, I guess would be the best way to put it, in regards to have you been able to break this mythical 400, and I hate to use the word MIP, but it seems to be an industry standard, but have you been able to break that 400 MIP barrier?
Absolutely. In fact, what we've found is these systems are running perhaps even better than we expected. Our customers should understand that before we ever placed a machine in the field, there were about 3 machine years of experience. And as of today, there are several running in customer locations, all of which installed quickly and on time and were turned over in full production in the next shift. So there's a great track record for both availability and performance with these new machines.
One of the things that's always important is upgrade paths. What are the upgrade options on the new line?
Well, if you look at the ES9000's upgrade capability, we are essentially keeping the commitment that we made in September of 1990. At that time, we introduced what we now refer to as the 340-based models. Those all upgrade to the new ES9000s being announced today, as well as the models we introduced in September of 1991. So from a customer's investment protection, actually investment enhancement perspective, there's total upgradability within the water-cooled line.
Now, one of the terms that is typically used is horizontal upgrades versus diagonal upgrades. Right. Are there any horizontal upgrades for our customers where they do not have to take, I hate to use the word, Roger, but have to take an engine?
Right. If you look at the 340-based systems, essentially all those are horizontal upgrades. For example, a 500 will upgrade to the new two-way system of the 711-based processor. So those are in fact horizontal upgrades. From the 520-based systems, it's engine at a time, but we believe the capacity increases are reasonable in those upgrade steps.
One of the most popular installed machines today would be the 720. Could you comment specifically on the 720 upgrade paths?
The 720 has a number of unique upgrade paths simply because of that very fact. There's a number of them installed. For example, the 720 can upgrade to the new 6-way. It can further upgrade to the 4-way processor, giving customers a range of upgrade options from which to choose.
Roger, you mentioned that you've had early installation experience already with the new water-cooled processors. Could you tell me where you've obtained that?
Caterpillar, for example, in Peoria, Illinois, has been an early user and a very satisfied one as well.
Well, essentially, the computer center, we used to always think of it as being the hub of the network. And we're a worldwide corporation. We export about 55–60% of our products outside of this country. A lot of that we manufacture inside. And we've got a very worldwide-based dealership program. So the network extends in about 62 countries, 23 out of 24 time zones. We've got about 216 dealers that we serve, about 20 manufacturing locations. And all those are connected through a network that end up coming through the Peoria data center.
In addition to the data center's worldwide network processing, it was responsible for all business, marketing, and some manufacturing applications. Prime shift required over 90% capacity.
We had been having complaints about batch turnaround time for my operators primarily. Jobs that used to get done earlier in the evening were now getting done later on in the evening, carrying over on into third shift, causing them some problems.
So we figured we've got to have a CPU upgrade. What we did then was look primarily at IBM's new processor, and we looked at some competitive offerings as well. Ended up IBM's deal was one that gave us the kind of capacity increase that we wanted, the performance increase that we wanted, the technology that we wanted, and gave it to us at a price that we thought was fair.
Caterpillar's solution was to upgrade their 900 to a new ES9000 water-cooled 8-way processor, model 982.
It was projected to take 12 hours to do the upgrade. We were very concerned about an upgrade of this magnitude because a considerable percentage of our workload is on this 900, and if something were to go wrong, we were very concerned about that. But indeed, it was projected at 12 hours. It actually completed in about 11 hours and 30 minutes.
It was just like the upgrade weekend. We went into it, started on a Saturday afternoon, lasted about 11 hours, I guess. I don't know, nobody called me. I came in Monday morning, asked a few questions. Everybody said everything's fine. I didn't have a customer call me. The customers didn't know anything happened. It's really nice. It's a nice feeling for a guy in my position not to have to worry about those kind of startup problems.
Caterpillar's upgrade to the 8-way processor saw improved performance of 60% and an improvement in response time of 20%. To achieve this, the new processor has several design enhancements, including an additional I/O processor, a fourth central processor per side, and an increase from 2 to 4 megabytes of second-level cache. The 982 allows Caterpillar several new features, including data compression, increasing DASD efficiency and improving response time, and asynchronous data mover facility, which efficiently moves large amounts of data between central and expanded storage.
We're seeing that the cost of storing data is much less expensive on the mainframe, and we're able to transfer and manipulate that data much better on the mainframe. It has given us the performance that we expected. We've had no reliability problems with it. We haven't even known that we've installed anything, except as we look at our reports, we got very good results. So we're tickled to death with the way it worked.
Turning now to the air-cooled processors, Roger, you had mentioned that there were 8 new models of the air-cooled processors. Could you describe to us what those models are?
The air-cooled processors are really a significant introduction. There's about a 50% across-the-board performance increase for the air-cooled models. Consequently, what you'll find is numerous upgrade paths. For example, today's 320 system, very popular, can upgrade to the new 511 uniprocessor to uniprocessor. Furthermore, it can upgrade diagonally. So from a capacity perspective, customers have a range of options from which to choose.
Now, what would be the top end now on the air-cooled processor line?
The top end of the air-cooled processor is a new model called the 742. From a positioning perspective, it's just about the same processing power as a 600J. So in a very small package, we've packed a great deal of performance as well as all the new leadership functions we talked about earlier. It's an excellent value system in the air-cooled product line.
Would you then say that there is a whole new opportunity for our water-cooled customers that are on, let's say, 4Js and 5Js to migrate to the air-cooled systems?
Without question, and that's one of the design points we've had in going after the air-cooled performance, is to give customers a much more affordable option in a new footprint while essentially having the same function they've perhaps only thought of as having in water-cooled systems previously.
Could you comment on the environmentals? Because if you're talking about migrations from water-cooled machines to your new very high-function and very powerful air-cooled machines, is there a significant difference in the environmentals?
There sure is. As with data compression, we're really focused on cost of ownership. If you look at the environmental characteristics of both the new air and water-cooled models, you'll essentially find that you achieve all this performance for virtually no increase in operating cost. So the things that our customers pay real money for, heat, power, light, and so forth, do not go up essentially while they achieve this great deal of performance improvement.
Roger, with the new air-cooled processors, have you had any early installation experience with them?
We sure have. University Hospital in Augusta, Georgia has been an early user of the air-cooled systems.
University Hospital is the second largest non-governmental hospital in the state of Georgia. We are a community hospital. We're a regional tertiary facility. We think of ourselves as the community hospital for Augusta, Georgia.
Providing exceptional health care means managing medical and business records in a convenient, efficient manner. University Hospital is doing this with the use of the new air-cooled ES9000 processor Model 621. The new processor offered the hospital many advantages.
One decision that contributed to replacing the old processor with the new processor would be environmental issues as well as space. Machine room floor space is quite expensive, and we were running out of floor space. By replacing the old processor in its entirety, we were able to bring in a new processor that probably requires only 1/3 of the cooling and power requirements of the old processor.
Beyond the environmental advantages of the new air-cooled system, the 9121 offers design enhancements. New applications can now be utilized due to improved performance and increased capacity.
One application that's somewhat new to us and exploits new technology that healthcare is dealing with is the imaging application. The product we use is IBM's Image Plus product, and with that we are adopting a enterprise solution for centralizing the storage of primarily paper documents on our mainframe. This has led to a better integration of the PC platforms and the LAN, but we see the imaging application being an up-and-coming application at our hospital.
Data compression will tremendously help in the image area. The digitizing of images takes a lot of disk space. That's, even though it's cheaper now, that's still expensive, and that's the biggest growing area in our machine room. So if we can store more data on a disk, then we save money ultimately.
We're in the process of hooking up fiber SCON channels. We have some need to process in what's called an LPAR environment to run multiple images of our operating system, and yet trying to connect that to I/O equipment is costly in terms of channels. The EMF capability will allow us to share those channels between these multiple images of operating systems on one processor complex. So that's going to certainly cut cost and give us some availability that we didn't have before. One of the biggest problems that customers like ourselves deal with is the stability of application software running in a teleprocessing environment. 90% of the outages probably that we suffer are due to ill-behaved applications. Now with the addition of the additional CISS ESA protection, we're now able to protect CISS code from application code and look forward to some additional support that will be there to make the application code themselves more stable and not step on each other.
In the healthcare arena and patient care, we cannot have long periods of downtime. Patient care takes us into the lives of the patient, and so that means that our hardware has to stay up and has to be available 24 hours a day. We can, by moving to an MP environment in this box, keep part of the box up, take part of the box down, but have 24-hour availability.
Roger, in summary, what would you consider to be the most important pieces of this announcement?
Plain and simple, Richard, these systems are best of breed. They're the finest in the industry, and our customers should feel very confident of these things from a performance perspective and availability perspective as well. The value-add functions we're adding are unique and should provide an advantage to our customers from a total cost of ownership perspective, as well as the fact that these machines are essentially available immediately. All the machines, models, and upgrades essentially ship within the first half of 1993. So the total package from value, availability, and performance is one that we are just absolutely delighted to bring to the marketplace, and one that we're confident that our customers will receive well.
Roger, again, I just want to say thank you. I know it's been 3 hard, long years of work to bring this product to the marketplace, but I'm sure our customers will be enthusiastic about it, and I'm enthusiastic about it.
Richard, thank you. It's been a pleasure being here with you.
What I'd like to turn to now is some announcements that we're having with our Enterprise Systems Connection Architecture, or SCON. With us today is Mr. Bill Keefe. Bill is our Senior Product Planner in the Enterprise Systems line of business for SCON. Bill, what are your announcements today?
Richard, we have a new box called the 9036 SCON Remote Channel Extender.
Bill, could you tell me what's the functionality of the new machine?
The purpose of the box really is twofold. One, to provide a smaller granularity of fiber conversion capability, and secondly, to allow us to interface to the common carrier's fiber plant.
Well, Bill, what is the role of the common carrier in this new solution?
Richard, the function of the product, there are really 2 primary functions of the product. One is to give our customers a smaller granularity of fiber conversion capability, and secondly, to allow us to interface to the common carrier fiber plant for channel extension.
A lot of what I've heard is that this addresses something called tactical right-of-way. Could you share with us what that is about?
Yes, Richard. There are several key applications being attempted by our customers now, disaster recovery sites especially, and those typically are geographically remote from their primary operating sites. That necessitates them to cross public right-of-way. That's where the common carrier comes into the equation.
Now, what's been your experience so far with the common carriers as you've worked with them to implement this new solution?
We had some difficulty in educating them a bit, but now they understand why we need what we need for the SCON extension services. They are very cooperative, and now we are making very good progress on providing a total system solution to our customer, which would allow him to take maximum advantage of ESCON distance capabilities.
Now, as I understand it, Bill, some of the RBOCs are already enthusiastically embracing your new solution, specifically Ameritech. Could you comment on that?
Yes, I've been working with all of the regional Bell companies in the United States and some foreign telephone companies as well. Ameritech in Chicago has publicly announced availability of such a service, and we anticipate that before the middle of 1993 that 5 or 6 more of the regional Bell companies will also announce that.
Now, could I assume from your discussion that the primary function or primary role that your announcement will play is in disaster recovery, or is it in other areas as well?
Well, disaster recovery is a primary application that people are trying to do. There are other secondary kinds of applications like remote tape vaulting, which is a less expensive protection mechanism being used for data, and also the need to remote printer pools, terminal control units, and auxiliary I/O equipment from the primary data center.
So again, this is a continued evolution of ESCON function. When will this one be available, Bill?
Richard, yes, this is a continued evolution, and this device will be available mid-year 1993.
And if you summarized your announcement today, what would you consider to be the greatest value again, Bill?
It's going to fill in one more piece of the puzzle for our customer to have a total system solution from the processor to his remote site for protecting his business assets, his data.
And will your customers be able to install this this year?
Yes, they will.
That is really fine, Bill. Thank you very much for joining us today.
You're very welcome, Richard.
I'm Walter Cronkite reporting again on IBM System 390 announcements, serving new expectations. The mainframe plays a vital role in protecting critical client-server networks and providing essential backup when there's a problem. As the next report shows, the mainframe does not consider itself just a fair-weather friend.
Hello. We're here today to speak with you about a concept and a mission which is reshaping the computer industry. It's called client-server. As you know, workstations have the power and capacity to handle numerous resource-hungry applications. And by linking them together on local area networks, their power and capability increases even more. So it becomes even more critical that their data be protected and that the LANs be administered and managed so that all users have the access and the information they need when they need it. To accomplish this, many local area networks use a single workstation server, simply because pooling resources makes sense. But nowadays, it isn't just workstations talking to each other, but different LANs talking to each other. With that comes increased power, capability, productivity, and potential problems. One problem, securing highly sensitive data. Workstations are very easy to break into, and anyone can walk away with hard disks or floppies. Another problem, recovering data needed by all the LANs when a disaster hits. That's where the mainframe comes in. One company which has already had lots of experience in distributing and protecting data among LANs and the main server is the Central Life Insurance Company, headquartered in Des Moines, Iowa.
One of the reasons that I believe that the future of the mainframe is as a file server is because the ability to back up and the ability to recover is so much more developed on the mainframe than it is on the PC. I believe that security and the ability to back up are the main strengths that the mainframe has over the PC LAN technology. It's going to take a long time to be able to get the LAN and PC technology to where the mainframe is currently. And the mainframe is increasing all the time, their ability to be able to do masses of data quickly as far as backing up and recovery.
But at Central Life, backup and recovery are used for many functions, not just after disasters.
In the LAN-based and PC arena, a key mistake that occurs is that applications are not tested thoroughly enough. Typically, applications were developed for PCs and LANs as single-user applications, tested as such. Then they're moved over to a multi-user environment, and it's an entirely different set of problems that occur. And it's exponential, the number of problems that you get into, because it affects backup recovery in a big way. For instance, we had 10 gigabytes of data on a LAN-based system. We could not back it up. We could not recover it. We estimated it was going to take 3 weeks to restore that amount of data on a LAN. The transfer rates from recovery mechanisms on LANs to the disk are just not where they are on the mainframe.
We were used to taking a large amount of data and backing it up every day. Companies like us had a very in-depth disaster recovery plan. We had to know how to take gigabytes of information, put it on tape, take it off-site, and manage that. Moving it from locally to off-site to a hot site, and had all that planned. So on the mainframe side, we really had a pretty good idea on how to do that. In the image environment, the PC environment, people didn't know how to do that kind of stuff yet. And we were certainly ones to learn as we got all that amount of data on the LANs. And it was a big concern to us, and we tried many tape backup systems on the PC systems that emulated the host, did disk management, that kind of thing, but it just took too long, and it took too long to restore. So the LANRES product has helped us meet that.
With the LANRES, we shut it down, dismount the volumes every night. Instead of being a modified backup, it's a full backup every night. I sleep a lot better. I mean, I was in here 18-hour days, and started getting to the point where I was scared about my job with the other one, whether or not it would ever get restored. With this, I know we've got a full backup every night. I mean, the worst thing that could happen if we had the disks crash, the thing fall apart, would be to get those same tapes back in there and have it back up to where it was the night before. And you could do it in an hour. So, I mean, like I said, I'm a lot more comfortable about it. It's something I don't really worry about.
LANRES is Land Resource Extension and Services. It's an IBM product for managing and recovering Novell NetWare LANs. We'll have more about LANRES and DFDSM, Distributed Storage Management, a bit later in this broadcast. But now, let's continue hearing about how Central Life handles security and recovery.
Security and data recovery, I think, will always be a corporate, central, controlled function. I believe that's where it should stay. I think you can't quite separate and have 100 people worrying about security. It's kind of a corporate need. I think the board of directors are looking towards a control function there, that you have to have one environment making sure that that data is protected. Our disaster recovery, the same issues there. In the PC environment, they've always worked with standalone PCs. And when someone's PC hard disk or something failed, they could always just go out, work with them, and not affect 250 other people. Now with the networks, everybody's connected. We're using networked hard disks, data storage. Everybody's got data that they can access for security reasons. They were looking for advice, and why reinvent the wheel when we went through it for the last 15 years, and it's been a great help.
Now, the last general area we're going to cover is network and LAN management. Let's take a look once again at the network diagram. Regardless of how the LANs are connected, a decision has to be made as to how they'll be serviced. Centrally, remotely, or let the LAN users do it themselves. The answer to this question can be quite expensive. A recent study by Nolan Norton and Company of 10 large American corporations placed the yearly non-hardware cost between $6,000 and $15,000 per year per workstation. One major part of the amount is for end-user training, the other part for LAN and network management.
Network administration and management and security in the PC environment is is a big concern to us today. And one of the things that we're learning is how to get that knowledge base built up. Certainly it's easier to keep that centralized, and instead of developing 100 people to get that same knowledge and put them out at all the remote locations. I believe that that is another area that's going to be hard to partition away. I think it's going to be a very big benefit to Central Life to keep it centrally located, get the expertise and the knowledge in those areas, and what's going to make that work is to be able for that systems administrator to reach out to all the networks from the home office and administer those networks.
And the key to all of this is the management, the network management. In our case, we have deployed NetView, and we have interfaced NetView with our LAN managers to be able to bring some of that control and be able to understand what's going on. Now you have a huge network, and where the data is located, it's not even located locally, it's even away from here. Our network management is located in a central facility by using NetView. NetView gives me the opportunity to even reconfigure remotely some of these heterogeneous networks that existed out there. It's so versatile, so flexible, that allows me to be able to take care of the problems even before the problems show up in the user's environment. So it somewhat automated me the process, and that is all done through our mainframe. So the mainframe right there is even a network manager. We run it through our NetView, which is installed in the mainframe environment. And when you have a metropolitan area network, as we do, and you have 6 PBXs installed, you have in excess of 2,000 nodes. Some of them are workstations and some of them are LAN. To us, are a node anyway. To be able to eliminate the dispatch of technicians on both ends to troubleshoot a problem by using NetView, I can tell you right now that I don't even want to disclose the savings, because I might have some headcounts cut.
We're going to turn now to something we mentioned before, DFDSM, Distributed Storage Management, which is the IBM product that uses the mainframe to secure workstation data. Bob Rogers is an IBM senior developer. Bob, what are the functions of DFDSM?
Well, DFDSM is intended to provide a solution for client backup today, where clients represent workstations out in the network. If you look at what's happening in most of the customer environments, what you see is that out in the workstations, the backup of the workstation is done probably the first day that you get it and never done again. And then the fact is that once one of these things crashes, and it will eventually crash of its own weight sometimes, then what you'll see is that the user is faced with a struggle to try and put things back together. With DFDSM, he can go into the user interface, ask for a file to be restored back to his workstation, and the server takes over, brings it back, the client puts it back, and everything's back and working wonderfully again.
What software and hardware configurations are necessary and supported by DFDSM?
Well, we've got a total of 7 clients and 4 communications paths to the server and 2 server systems. The 7 clients are DOS, Windows, OS2, NetWare, Sun, AIX, and Macintosh are 7. And in terms of communications, we've got PWSCS, a programmable workstation communications services, LU 6.2 for a SNA network support, LU2 for terminal communications, and then finally TCP/IP. So those clients, those servers, and then MVS and VM, it's a really simple system on MVS. Requires basically any supported MVS SP, either version 3 or version 4, and the DFP version 3 or DFSMS MVS. On the VM side, it's a whole raft of the current VM operating systems, although we'd like to see everybody running VM ESA 2.0.
Tell us a little bit about the ESP, the early ship program for DFDSM.
Well, the program that we're running is really neat. I've been working with it ever since it started. We've got 2 programs that we're running. Field test that we started early in the program, where we said that we really wanted to understand how the code works in customer shops before it's finished. So we began shipping code in iterations to customers. They looked at the code, they told us what they liked, they told us what they didn't like, and they put it into a sandbox environment, exploiting as many of the functions as they possibly could. We've subsequently moved from the field test level of the code into something we call a quality introduction program. The quality introduction is expanding it to dozens of accounts and much closer to a GA readiness condition. And the experiences to date with the customers have really been great. We've got the code running in over a dozen shops. Even though early on we said that the code should be sandbox only, don't use it in production, we had several accounts who said this is better than anything we've ever experienced. They went ahead and put it on dozens and now hundreds of workstations, or well over 100 workstations, using it in what you or I would probably call production. It's a real compliment to the developers that we were so successful that they said, we don't care that it's not production level code, it's providing such valuable services that we need to have it, and we're willing to go ahead and work with it. It's really great.
You mentioned GA. When will DFDSM be available, and on which platforms?
Well, all the platforms are going to GA at the same time. So the 7 clients and the 2 server systems all GA at the same time. We didn't announce a GA in the May 19th announcement. What we said was that we're going to run this quality introduction program, and at the conclusion of the program, we're going to assess what the customers think and make sure they believe it's ready to go. And that's why we're running these series of programs, so that at every step in the way we can assess what the customers feel, go ahead and make changes. This program represents really a new step in terms of getting software out, in that we're spending much more time up front making sure, confirming our design, altering the design, and making changes. The customers are just ecstatic over the fact that we are making these changes. It represents really, responding at a very, very fast level to the requirements. I haven't answered your question about GA, and that's by far the most prevalent question that I get from people. When is it going to GA? The answer is just as soon as it's ready.
Okay,
we haven't announced.
Sounds good. Finally, is there anything you want to add or tell our customers about DFDSM that so far you haven't covered?
Well, probably the most important thing to say about DFDSM is that as you look at environments, there are 2 questions that come up. I have zillions of client systems out there. Will this handle the load? And the answer is a unqualified yes. The technology built into DFDSM represents state-of-the-art technology, 1993 technology, not even cooled off technology. So if you think about what customers are managing today in their environments, they're accustomed to seeing terabytes worth of data. We're building this for petabytes worth of data, thousands of times more than what they see today. And I think that in terms of the extendability of this, in terms of providing the functions, this is without parallel.
Bob, it sounds great. Thank you. Thanks for your time today.
Well, you're welcome.
For Novell Networks, LANRIS, Local Area Network Resource Extension and Services, is an IBM product which supports LAN administration of multiple local area networks from the mainframe. Wes Richard is an IBM client-server consultant. Wes, what are the functions of LANRIS?
LANRIS has 4 major functions. The first function is the ability to do active disk serving for the Novell NetWare server from high-speed and high-performance disk drives up on the host system. The second major function for LANRIS is the ability to do print serving. And when we do print serving, we have bidirectional queues that go from the NetWare server to the host, and vice versa, the host down to the NetWare server, which gives the ability for users to either print out 3270 applications on their workstation-attached printers, which are controlled by Novell, or to go ahead and print workstation data on high-speed host printers. The third major function of LANRIS is LAN distribution, which is the ability to go ahead and move files from the host system to the Novell drives, which are actually located up on the host system, saving network bandwidth and enabling high-speed transfer of those files anytime the user wants them. Fourth major function of LAN-RES is administration. And the administration takes the form of being able to control a LAN environment with multiple Novell NetWare file servers, being able to control it centrally from the host, with also automation so that you do not have to go through the amount of work to transfer files, to set up system commands from server to server.
What software and hardware configurations are necessary and supported by LAN-RES?
Currently with LAN-RES 1.0, the hardware configurations include everything right now that is supported by Novell from the local area network out, which is DOS workstations, Macintosh, Unix workstations, or they could even be OS/2-based workstations. So it's completely transparent to the NetWare server as far as the LAN side of the house is concerned. As far as the host is concerned, with LAN-RES 1.0, we put a channel adapter inside the Novell NetWare server, and we channel attach it into the host system, and that's all that's required.
When will LAN-RES be available, and on which platform?
LAN-RES is currently available today, with the exception that MVS does not have currently the print function or the administration function. LAN-RES 1.2 will be available at the end of March. It will include both the print function and the administration function, as well as other functions for both VM and MVS.
So LAN-RES is already out there. How would you characterize customer acceptance of LAN-RES?
Customer acceptance of LAN-RES has been excellent. For customers that are pushing today's hardware past their physical limits in terms of applications such as image or multimedia, or just the amount of disk storage that's required on the Novell NetWare server, or if they're overrunning their current PC printers with print jobs, have seen tremendous benefits with LAN-RES. The repeated comment I hear is, "This is too good to be true," over and over in the different demonstrations that we've given, and in the installations that we have installed today.
Is there anything else you would like to tell us about LAN-RES?
Yes, I think LAN-RES, as far as customer acceptance goes, is going to be very good when customers learn about the product's features and functions. So I think it's merely a matter of getting the word out. And I think they will also say, "This is too good to be true."
It does sound great. Wes, thank you for coming in.
Thank you.
There are many ways in which client-server can benefit users. But what happens when you want to make sure that users on Sun workstations, and some on Macs, and still others on PCs can all talk to each other? That's where Advanced Client-Server comes in. The 3Com Corporation in Sunnyvale, California, manufactures and develops networking equipment and uses the mainframe as the integrating serving platform. 3Com is a direct competitor of IBM in marketing token ring adapters. But 3Com executives selected an IBM ES9000 to digest volumes of daily manufacturing and sales information pulled in from PCs and Macs around the world. They call this client-server executive information system 3Info.
We wanted to provide users with better access to information, and we wanted to achieve that through creating a set of corporate repositories that contain complete set of information about customers, products, sales, etc., etc.
And we needed to supply information that was timely, that was easy to access, and that was flexible. And so we went out to look for a solution that would provide this global data information and looked to put in an information repository and selected the IBM hardware and software to implement this solution.
It's made quite an impact on our business. Let me give you a little example. About a year and a half ago, I needed a report from our MIS department that would tell me by customer what products the customers are buying. Whether it's a hub for one particular OEM or a router for another. It took a month and a half to actually get the report that we needed. With the new information retrieval system we have now, the information's updated nightly, the access is incredible, and the feedback we get is so timely, we're able to make the right decisions on manufacturing, the right decisions on inventory now.
From a networking standpoint, things change very little with the advent of the ES9000, which was part of the 3Info system, a key part of it. It fit very neatly into our current network architecture. It was a different architecture for us than it was token ring based, but we simply brought that up online, connected it via a gateway to our primarily Ethernet based network, and we're up and running literally transparently.
Some of the comments that we got from our users, especially those who were familiar with our existing transactional environment, the comments were, wow, now we can get the data in minutes instead of days. So the difference was just absolutely dramatic. People just were so happy that they don't have to go to a third party and ask for information.
And you can't place a value on the immediacy of data, because there are times when you could win a deal by having that data at your fingertips where you would lose it otherwise.
The reason we chose IBM was that IBM ranked very highly in the majority of the criteria that we set up, and nobody else out there was doing what we were trying to do, and we had a lot of trust in IBM's ability to bring in the best of talent to help us put this solution together.
The solution has far exceeded all expectations and has been incredibly successful. Some of the harshest critics of the system are now the staunchest supporters.
When we first started, we were actually very concerned about the connectivity. We thought that that's a very tough challenge for us because we had to provide cross-platform, cross-network, cross-mainframe connectivity.
It's a 5,000 node network spanning over 40 local LANs. We run 7 protocols and pride ourselves on being a multi-platform LAN, so we have Macintoshes, PCs, Suns, a wide variety of PC platforms, and a very broad variety of software.
It is a great client-server application. You've got a powerful database at the back end with well-structured libraries of information and the most flexible tools on the desktop possible, state-of-the-art tools on the desktop.
Our budget was $1.2 million, and that included hardware, software, training, as well as integration services that IBM provided, which actually was the lion's share of the budget. We went over budget maybe by 2 or 3%, which was very, very good. And actually the whole project was, from start to finish, took 5 months, which I think is an incredible achievement.
The system is oriented around graphs, and I can get to the data and see it visually, allows me to see the underlying trends. So the system today gives me 2 things. Number 1, I get the information quicker. Number 2, I actually need fewer staff people to develop and cut the data, since I can do it myself.
I absolutely see the level of cooperation between IBM and 3Com increasing, and I expect to partner with IBM both in MIS solutions and in data networking solutions for our mutual customers.
I'm Walter Cronkite with an expanded look at the concept of open systems as our System 390 announcement coverage continues with the theme, Serving New Expectations. IBM says it has made a conscious effort to help encourage shared technology by making its equipment more compatible with that of its competitors. The range of views on open systems is wide. Sit back now and look at those views.
To be able to integrate all our different systems, to get away from proprietary, being able to plug and play, to be able to run the applications on any of my workstations, my Unix workstation, that would be open.
3 things that I like to see in my computing environment. One is I want interoperability, because we need to serve our customers, and our customers have the products of many, many different computer vendors. The second requirement is portability. The third requirement, which is perhaps more generic to everybody, is that we would like to be able to operate this complex distributed computing network, and the nature of our business requires we have a distributed computing network. We would like to be able to operate that as efficiently as possible.
Our idea of open systems is making that our responsibility of tying all that together in terms of how it communicates, how the data works, and how we can satisfy our customers' needs from that really widely varied group of information systems vendors and software and so on from around the world.
There is agreement among users that open systems are a critical component in their day-to-day operations to solve business problems. In 2 or 3 years, it will be a fact of business life. That's important information for IBM. And what's equally important is understanding what it really means to be open. Customers have their own definition of open, and it's as different as their businesses.
We have open systems support in all of our systems today, and that includes the AIX systems, which are of course based on Unix and many of the widely used Unix standards, as well as on the SIA systems, as well as many common standards and protocols that are used across the system. So we have support for the TCP/IP for OSI, as well as SNA communications on each of the systems. We have SQL databases, we have a variety of languages, and we have support for emerging de facto standards such as the Novell LAN support on each of the systems. Yes, open systems is not a new concept to IBM. In fact, we've been supporting standards and supporting openness for a period of time. Well, I think what is new is that there's a growing emphasis on open systems in today's market. And as a result, IBM, being a market-driven company, is paying attention to that increased emphasis and is responding with additional investments in this area. When we started to look into additional nuances in open systems, or the additional meanings of open systems, we chartered an independent research company to go and gather information on our behalf. And they talked to several hundred customers in the United States, in Europe, as well as in Japan to get their meanings of open systems. In today's world, what we're finding is that there's an increasing interest in open systems. In a recent study, 77% of our customers told us that open systems was a subject which was either extremely important or very important to them. And that's growing. When we ask them what percentage of their, when we ask them whether their systems were open today, 21% of the customers told us that their systems were either very open or totally open today. But when we asked them about the future, what the customers told us was that 52% of them expect their systems to be significantly more open in the next few years, and we asked when, and they said over the next 1 to 3 years. So this significantly increased attention to open systems is a fact of life in the marketplace that IBM is paying close attention to.
I've seen evidence that IBM is serious about open systems. Advanced function printing architecture is an excellent example. That's been a documented architecture and available for other vendors to write to and to provide products around. In Print Services Facility 2 as well, I see more indication that some de facto standards in the industry are being incorporated into IBM products. I'm confident that IBM will be a force in open systems in the future.
Yes, IBM is open for business. To address those business needs, IBM announced MVS Open Edition Services. It is a strategy that works now and provides a foundation for the open systems of tomorrow.
Open Edition MVS is a connotation that we're using with the operating system to help denote that there are a set of standards, be they formal standards or de facto standards, or even requirements by special bodies such as NIST, the National Institute of Standards and Technology, that they require in order to meet their needs. And so we use the term Open Edition to help the customer to perceive, to help the customer to identify what standards we provide. And we commit to document those in our materials so that they can clearly see what things they can depend on being within our product. Open Edition MVS provides a set of services initially which meet the POSIX.1 and POSIX.2 standards, as well as the NIST FIPS 151.
We initially announced that we were doing POSIX.1 and POSIX.2 compliance on MVS. Well, we started looking at the DCE, the Distributed Computing Environment from the Open Software Foundation. That's dependent on a threading package that comes from the Open Software Foundation. Well, our POSIX implementation is really built into the guts of the operating system. It's not a bump on top of MVS. It's really a part of it. It's not a separate environment, and the expectation is that our application environments can use the POSIX services at will. Well, with the DCE being coming originally from a Unix environment, we felt that it would be very productive to port that DCE technology onto our POSIX services, and then as a result, providing that threading facility in the operating system has enabled the DCE to be ported that much faster, getting the DCE closer to the base operating system versus a bump on top of it. And as a result, we provide hopefully a much better integrated solution than we had to based on the Open Software Foundation's definitions. By their definition, DCE could have gone into some user's address space, all link edited with one application. We're bringing it into the base operating system so that everybody's using these shared resources, and as a result, you should get a much better implementation on our platform.
It's very important to realize that we are not adding POSIX to the MVS system. What we have done is integrated POSIX. We have extended the existing system with additional interfaces. The subtle difference is that when you extend the operating system, things like the new file system are able to exploit the existing facilities of MVS, such as DFSMS for the system's managed storage. That is a very important component of what we attempted to do in our implementation of these interfaces.
We took what might be considered an architectural approach, which was we tried to sit down and decide what was important to us and put in place the framework for a long-term commitment to a way of doing business. A big part of that was thinking about the infrastructure that supports the sharing of information. And in that area, we articulated some principles and some sets of beliefs about how we wanted to operate. We built what might be considered a model that was based on the International Standards Organization's Open System Interconnect model.
The standards are trying to provide that vendor neutral or that common ground such that the customer feels not a guarantee but a comfort feeling that the products will work between the, different vendors. What becomes real important though, in the past, IBM, at least at the mainframe level, we spent a lot of time trying to differentiate our products, showing the value above and beyond what any other vendor might provide for their product. Now in the open world, we're really trying to distinguish ourselves, but really show how we're providing that architecture of our mainframe operating systems or any operating systems transparently to the customer so that they get the value of the scale of the processing at the mainframe level so that they can participate and exploit the strengths of our systems but still get that warm, comfortable feeling that they get from the open systems that enable them to interconnect or port applications from one platform to another one.
The availability of MVS ESA, which supports these standards, will be the first quarter of '94. But we have already had the system running. It has been used in RPI.
The ability for me to take my Unix application and plop it on the mainframe and not have to worry about it. That's really the major benefit that all of us, at least in the computer science department at RPI, see. We don't have to program to MVS. So it's another platform. It's an easy port. We've already found that out. Didn't expect it originally to be that easy, but it's a pretty easy move of our code. So it's another platform. It's a very powerful platform. Obviously, this is a mainframe computer we're talking about. So I've got my software. It takes a week on a Sun. Let's see what happens on a mainframe.
We have also had within the month, we have had an independent testing organization which has validated that MVS will conform with FIPS 151. So we are doing a lot to exercise and validate our product before making it generally available.
What we're trying to do is meet using known test suites, standard test suites to prove conformance to the particular standards. But those only give us, those really show the spirit of our commitment. We've got to back that up with a guarantee that we will conform to any other problems that pop up, maybe that weren't part of the test suite. We're going to do additional work, though, to prove beyond the POSIX work, like with the Open Software Foundation's distributed computing environment, as that product comes out, looking for certification that we meet that format and protocol, those set of standards that the Open Software Foundation is dictating. So we're trying to certify ourselves in as many product suites as possible where we have products available. Well, right now we have a statement of direction available on MVS, on AIX ESA, and just now with VM has announced a statement of direction for DCE. The interesting news that really hasn't been released yet is that we are in beta test of the DCE on MVS at about over a dozen customers right now, and they're just starting to roll that technology in, so that there is some feel that yes, this is doable. We're demoing the product already at different user groups and things like that, but the technology is rolling out, and hopefully we get it out there as soon as possible. But it can be done. Something that a lot of people didn't believe, we could bring that type of Unix technology onto our platform.
Computer science in general is trying to spread out everything. Distributed computing, for many people's eyes, means everyone shares disk. And in computer science research, we're actually pushing that much more. We're distributing computations. We're distributing all kinds of things, everything we can find, because we tackle problems that are so big we can't do it on one computer. So the mainframe running something like Open Edition MVS will provide us a nice way to use that resource without specifically, gearing our entire research project towards just the mainframe. We just focus on our research, not on what is going to run our programs, what is going to provide our data.
We will begin in April making the MVS system available through the Open Systems Center and through the porting centers for other vendors who wish to ship products which run on top of MVS.
The Open Systems Center in Dallas has had a number of successes in terms of helping customers build multi-vendor solutions. In fact, we have a floor there that has over 80 non-IBM systems in addition to a full range of IBM systems, and we're able to build together to do prototyping and proof of concept work to show customers the best ways to tie together their IBM systems and non-IBM systems. And we're in the services business in terms of helping customers design and build multi-vendor solutions.
People from the Multi-Vendor Coexistence Center in, I think it's outside of Dallas. And they brought two people up that were probably some of the best people I've ever seen in understanding and explaining some of the concepts behind open systems, and particularly open systems networking. Now, we have a multi-vendor environment. I mean, the reality of our situation is we have Hewlett-Packard design systems, we have digital design systems, we have lots and lots of different kinds of PCs, lots of different protocols, lots of different networks. And we weren't going to take it all out and put something in that was an IBM seamless approach. We had to make what we had work. And these people were people that had intimate knowledge in all of those components. Not only that, but instead of talking to us in high-level conceptual vague terms, they could show us where the things were actually working.
I think in general, for the future, we're looking towards more portability of our applications, which means that the enabling software like DAE, PlantWorks, the operating systems that are used on both the smaller and mid-range computers must be portable. It's very important to us from a strategic standpoint, as well as, quite frankly, day-to-day productivity of our applications programmers, and the need to get out of having a lot of technical gurus on the payroll. We have to have life simpler in the open systems arena.
Strategy is really to address 4 areas in open and distributed computing, at least on MVS, and it's to enable client-server technologies for interoperability between systems. It's to provide transparent access to our existing services in the areas of database and transaction processing facilities. It's to enable application portability across multiple vendor systems, and it's to provide for system management facilities that improve on the overall system management of a heterogeneous distributed operating system.
IBM is going with open systems is far beyond providing standards. The foundation is a rich base of platforms and products that satisfy the market requirements. And we talk about standards quite often, but it's really more than that. It's what the customer is expecting between many vendors that he's looking to buy from. IBM's strategy for supporting open customer requirements is much more than providing only standards conformance. That's kind of the nomenclature that we've been using to help the customer, to help our marketing force identify what it is we provide. And the standards provide a handy reference. But we have to go beyond that. We have to work with other vendors and identify products that we will sell to our customers to satisfy their needs. MKS, a vendor out of Toronto, provided the code that meets our POSIX.2 standards conformance. We are joining with other vendors to license and release their products. Finally, our direction will be to work with skills that we have within IBM to bring all this to the customer with services and activities that help him meet his business requirements, bringing together open systems products that satisfy business goals.
I'm Walter Cronkite. We're back with more of IBM's extended coverage of the System 390 announcements, serving new expectations. IBM has prepared for you a special in-depth report on the multimedia revolution and the way multimedia is being used at Rensselaer Polytechnic Institute in Troy, New York.
Hello. We're here today in Somers, New York, and we're going to be talking about mainframes and multimedia. Joining us is Bob Steen. Bob is the Enterprise Systems Director of Client Server Solutions and has solutions responsibility for client server, multimedia, and image processing. Bob, thanks for being here today.
You're very welcome.
Bob, the mainframe has a new role in life. Through the 90s and beyond, it's going to be used as a big server, if you will, in the client server environment. One of the best features is how it handles multimedia applications.
You're absolutely right. We're trying to reposition the enterprise systems line of business over the rest of this decade in the early 2000s. The environment in our customer locations is clearly changing to a client-server environment. In many client-server complex installations, the mainframe, the enterprise systems machines, can be the server of choice. Multimedia is a very good example of an exciting new opportunity where the mainframe can be a server to deliver all kinds of media, but in specific full-motion video to our customers' locations. This is a very exciting opportunity for enterprise systems and for our customers, and we're planning to work very hard to put together the right solutions consisting of hardware, software, and services to provide the best multimedia solutions for our customers.
Bob, what is the enterprise systems strategy for maximizing its participation in this new opportunity?
Well, our strategy is very simple, and it's two-pronged. Number one, there are a lot of legacy applications installed in our customer environments today that are online transaction processing systems running on CICS or IMS or DB2 that people want to front end with the ability to deliver different kinds of media to their customers. A real good example of that is a kiosk if your customers are external to your organization. For example, the state of California is putting kiosks all over the state of California in shopping malls and other locations where you can walk up to a kiosk and do your business with the state of California, whether it's paying a parking ticket or renewing your driver's license or whatever you would have normally had to go in to a town hall or a police department to transact your business. This is a wonderful application for us and for our customers because it takes applications that are already running today and puts a front end on them that allows us to deliver multimedia to our customer set. And in the state of California example, there are 30,000 employees in the state of California, all using the state of California processing systems. There are 30 million residents of the state of California. They want to take the usage of their systems from just the 30,000 people to all 30 million people. And obviously, that's good business for both the state of California and for IBM. So the first part of our strategy is to take these legacy applications that already exist and front end them with multimedia capability.
That's something we can do today, and that's something we're hard at work doing. The second part of our strategy, though, is to take brand new opportunities, applications that haven't existed in the past, install those with a multimedia capability, and probably the best example I can give you is full motion video. There are many, many customers, telephone companies, cable companies, entertainment companies, that have hundreds or thousands of hours of video that they want to deliver either locally or remotely to their customers, and they want to be able to do it with high quality and with very good price performance. So we are in the process right now of developing an ES9000 multimedia server to take hundreds or thousands of hours of video, store them on disk, and be able to transmit them either locally or over telephone lines to a wide variety of customers, either homes, businesses, whatever it is our customers want to do. You can just think for a minute about the entertainment industry. If you want to rent a video for your home, right now you have to get in your car, drive to a store, look through the inventory in that particular store, and pick a video that they have in stock. For example, if you wanted to rent Terminator 2, and they had only bought 15 copies of Terminator 2 and you were the 16th person to show up that day, you're out of luck. You're either going to rent nothing or you're going to have to rent your second or your third choice. With an ES9000 as a multimedia server placed somewhere strategically in the geography, that store can both eliminate their inventory, so dramatically lowering their costs. And right now, on our first step in working with these entertainment companies, if you were to drive to the store, they have no inventory at all. You go up to the desk, tell them what movie you want. They download the movie of your choice to a blank cassette. You rent the cassette, you go home. There's no limit to the numbers of copies of a certain movie they can deliver. Obviously, step number 2 will be to eliminate the store altogether, have that delivery be directly over the cable to your home, and now all you have to do is call the cable company and have a movie delivered whatever time, whatever movie you want at whatever time you want. Now, entertainment is probably the most interesting application to talk about, but it is really corporations who want to do on-demand training that is the real 1993 opportunity. Our customers want their employees to be able to sit at their desk in their office with their workstation and be able to call on demand whatever training it is they need to be able to do their job better or to be able to do a new task that they've been assigned to. So we want to be able to provide the facility for you to call up a training video, either an entire course or just a few minutes on how to do a specific function, and do that on the workstation, on your desk, in your office or in your workplace. That's a huge potential opportunity for IBM, for the telephone companies, for the cable companies, and certainly a huge productivity increase for any company that installs this kind of application. So it's an exciting area where we're really trying to go after legacy applications that already exist and brand new applications which have never existed before, but which the cost of the computer and the telephone company hardware is getting down now where we can start to deliver these kinds of multimedia applications. So it's a really dramatic new area for IBM and for our customers.
Recently, IBM did something pretty unique. It took a model 9221 to Comdex, a show about PCs. What was the 9221 doing there?
It was an unusual step for us, but one that's turned out very, very well. The Comdex show in Las Vegas was just before Thanksgiving, and it was one of the most incredible things I've ever been to. There were 116,000 attendees at Comdex. There were 7 convention centers at Comdex full of demos, primarily, as you said, about PCs and associated PCs equipment. However, one of the hotels, Bally's, was devoted to multimedia. So there was nothing in the Bally's Convention Center except multimedia demonstrations and exhibits. IBM had taken a 9,000 square foot booth in Bally's, and we really wanted to put our best foot forward on IBM's capabilities for multimedia. The heart of the booth was a very novel concept where we had a wall of servers. So on one wall in our booth we had a PS2 serving client-server multimedia applications. We had an RS-6000, we had an AS-400, And we had an ES9000, and it was, as you stated, a 9221, which is a small rack-mounted ES9000. We had local multimedia demonstrations off of each of those servers, and the primary demos off the ES9000 were video on demand. So it was full motion video coming locally off the ES9000 to 25 different workstations that we had installed around the Comdex booth. Those demos were both IBM demos and demos from software our business partners supplied. In addition to that, we had several demos coming remotely over telephone lines from other ES9000s across the United States. Probably the one that got the most interest was a demo which was coming from Ameritech. Ameritech had an ES9000 in Chicago, Illinois, where they were hooked up to our demo center in Las Vegas, and we were sending television commercials on demand. So you could walk up to the workstation and demand the commercial you wanted to see, have it downloaded from Chicago and view it. The performance was excellent, just like you had put the tape into your own VCR, and people were amazed at that capability because not many people realized we had the ability to do that kind of thing today. So we can do it today in demo. We're working with Ameritech and several other companies to be able to do it in real life, delivering full motion video to our customer set. It was very interesting. While I was there in Las Vegas at Comdex, I had several reporters who wanted to do interviews about why we had brought the ES9000 to Comdex, since it seemed unusual. And their first question in all of the interviews was always the same. The first question was, why did you bring an ES9000 to Comdex? Doesn't seem to fit in bringing a mainframe to a PC show. After a 30-minute interview, they all understood that there are certain multimedia capabilities that the ES9000 has that no other platform has today, and therefore it made very valid sense to bring an ES9000 to Comdex and to show off those demos both locally and remotely.
Bob, it sounds like the ES9000 generated a lot of interest at Comdex as a server for multimedia. What kind of comments did you get, and what kind of customers are going to be working with IBM on this new technology?
The comments were almost universally favorable. There were one or two reporters who were published and saying IBM's really trying to push mainframes everywhere, because they even brought one to Comdex. So there were a couple of negative comments, but the comments were overwhelmingly positive, because this is a capability serving hundreds or thousands of videos and hundreds of concurrent users that only a mainframe can do today. So the press comments were favorable, the customer comments were favorable. We had two customers that visited our booth at Comdex who asked for proposals for an ES9000 to do this application at the end of the show. So the people in the booth were scrambling. Not only were we doing the demos and putting on the shows, we were also helping the account teams write proposals, which are going to relate in specific business. I should point out that this capability is a result of a project that's been ongoing for the last couple of years in our research division in Hawthorne, New York. So we have an ES9000 Model 320 in Hawthorne in our research facility, which has been viewed by literally hundreds of customers over the last couple of years. And that was the demo we essentially took to Comdex, and that is the reason that we're getting such good customer reaction. This is hardware that exists today. This is software that exists today. The file server is a product called WLFS, which is deliverable today. So this is a solution that can be installed today. We have lots of interest from telephone companies, and we are planning to do prototype kind of joint development work with several telephone companies to put ES9000s in as servers and use their lines to deliver full motion video. We are working with cable companies, and we're working with lots of customers who want this for an in-house training kind of capability. IBM uses this capability ourselves. In the Mid-Hudson Valley, we have set up for our manufacturing workers the ability for them to walk over to a PS2 and pull up a video if they get in a problem in the manufacturing process and really need to be shown exactly how to install a part. So IBM uses this technology. IBM is going to be a provider of this technology, and we are working with many companies across the world, phone companies, cable companies, and other customers, to be able to provide this. I see 1993 as kind of a pilot year where we'll be putting in pilot systems in many different companies across the world. But I believe in 94, 95, and 96, we'll really see a significant difference in our business because of the capability of being the world's best multimedia full motion video server.
Bob, is there anything else that you would like to add about multimedia and the mainframe?
No, I think we've covered the major points today. I'd just like to close by reminding people that as we move from a mainframe-centric, host-centric kind of world of computing into a world of client-server, the mainframe, in many cases, will be the server of choice in a client-server environment. So even as the computing environment changes, the actual products themselves can remain the same, only the usage needs to differ. Client-server is an exciting new opportunity for enterprise systems in general, and the specific use of the ES9000 as a multimedia server is going to be a very big new opportunity for us as time progresses.
Bob, thank you. Thanks for your time today.
Thank you. I appreciate the opportunity.
Something old, something new. The turreted campus of RPI in Troy, New York is known for excellence in technology and excellence in teaching. So it's no surprise that people here are world leaders in the burgeoning field of interactive educational multimedia. They are creating materials that not only teach effectively, they provide students with up-to-date information they need on demand. Watch as RPI's Dr. Jack Wilson demonstrates how multimedia works. The subject is physics. The topic, how a bridge can be destroyed by harmonic vibration.
Scientific multimedia requires more than pretty pictures, and these indeed are pretty pictures. Let's go directly to a frame that shows this bridge in its maximum deformation. We have the capability to acquire data from this video using the mouse to place the origin point, and we place it on a node on the bridge. And begin now to put in the data. Put a point there. You see X, Y, and T appear in the data table, and another point, and another X, Y, and T, and so on along the edge of the bridge. For a scientist, it's very interesting to see this bridge oscillate, but immediately we want to know, what's the frequency of oscillation? What's the wavelength of oscillation? The amplitude of oscillation? We could find answers to these questions using this tool. If we go forward 11 steps, that's going to be 33 frames, 1.1 seconds, and now lay down data, and you see the new time appearing in the third number in the data table. Data's not much use to a scientist or an engineer unless they can do something with it. What I want to do here is turn off the video for a second so that you can get a better look at the graph we've just created over the video. Once we have the spreadsheet up, the data's in it, it's been transferred, all of these tools share data. You're able to rescale that data, take into account the perspective, rotate it, fit it to a sine curve, and measure all of those things that we mentioned earlier.
Like a force of nature, multimedia cannot be denied. Wilson and his students are creating such materials for interactive learning in many subjects, and they are working with other multimedia materials developed elsewhere. But they found there were problems.
One of the things we ran into right away in our implementation of multimedia with the management course, the physics course, chemistry, engineering, and as we began creating these multimedia classrooms around the campus, we realized that we had a tremendous maintenance problem on our hand of keeping all the materials in the classroom up to date, keeping all of making available all of these multimedia materials on each of the platforms and having them be consistent. So there had to be some kind of a central way to manage these. Also, there's a tremendous volume.
So Dr. Wilson has decided to distribute all of his school's multimedia materials from one source, an IBM mainframe, the ES9000.
Working with the mainframe, we'll be able to solve a lot of those management and distribution problems of multimedia. Working with the mainframe, we can have a central repository for all of the multimedia information that's used in all of the classes. This will allow us to deliver that material to the particular classroom when it's needed and not to have to maintain it in that classroom over a fairly long period of time. With one central area, we can make sure that we've got a consistent set of material for all the students, and the students will eventually be able to access this anywhere on campus.
The large-scale systems offer reliability, great processing power, very large and effective and high-speed disks, and in our particular case, we already have this infrastructure in place to do scientific computing plus some information processing at RPI.
The capacity for storing a lot of video information, visual information in the mainframe is a very important part of the whole thing, because as you know, the quantity of information stored for a few moments of video is huge.
To store 1 minute of video fills 10 megabytes, but for the massive storage capacity of a system using the ES9000, that's a drop in the bucket. The ES9000 can also handle heavy communications traffic, input and output, with super-fast response.
What a mainframe happens to have is a very good, fast, high-volume I/O bus. Well, that's just ideal for serving large amounts of high-bandwidth information like multimedia.
We've done comparisons between how well the mainframe serves as a file server in terms of speed and how well all of our file servers are RS6000s, very fast server platform, but the mainframe still can provide better performance in our environment at the moment.
So the mainframe, I think, is the thing that's going to make the difference. Without the mainframe, in a large university, it's going to be very difficult to administer the multimedia. But with the mainframe, I think that it will be economically very efficient, at least the initial numbers look really good, and it's going to be educationally very effective because they'll be so widely available.
The whole idea of networking mainframes and terminals is to get everything from everywhere to anyone, anywhere.
At RPI, that means being able to serve several existing platforms for user interface.
We've got an RS6000 over there, we have a PS2 Model 80 there, and on the PS2 Model 70 over there. And the advantage to having these things networked and being able to bring the video to the particular student's platform is that every student will have access to this kind of video at every terminal on campus. And that's our ultimate goal. We're started on that. The ES9000 that we have over in the Voorhees Computing Center is the perfect multimedia server. It's the server that a lot of companies are basing their strategy on. We think that that what will eventually happen will be there will be regional networks of multimedia servers, and those regional networks of multimedia servers will be able to provide this over a very wide area, and therefore it'll be kind of like a lending library for information that a consortium of universities can have access to the same material. In a regional approach to multimedia servers, you will want the ES9000 here at Rensselaer to talk to ES9000s and other sites to be able to exchange the multimedia information to make it available in all areas. That is under a lot of study by our Information Technology Services, and although we haven't done it yet, it's clearly in our plans for the future.
With a system based on a mainframe like the ES9000, such a multimedia lending library could easily accommodate the ever-growing volume of multimedia materials, including full-motion video, and the materials being circulated could never go astray and could always be updated if necessary at minimal cost.
In 24 months or so, a lot of people who never heard of multimedia will be using it not just in education but in industry and other places.
This multimedia technology will just remove all the boundaries, availability, and it will just make information available to anyone, anywhere in the world.
I've really come to appreciate the importance of these other issues, the ability to administer, to distribute, to deliver, to back up, and to store vast quantities of information that will be absolutely needed in the future for multimedia. And I have to admit that I see a really renewed reason for having that mainframe on campus.
It's very simple for us to move to this multimedia environment. We have to get the WLFS software integrated into VM CMS, and we expect to be able to do digital video to PS2s that have DVI cards in them relatively easily.
I can't think of anything that could handle it as well as a mainframe.